the addition of a new technology called Spark into our mix. So as many of you know, Yahoo spent a huge amount of investment on the Hadoop. Right? We started the Hadoop development for our search advertisement, so we made it open source for Apache. Many of you are benefited from the open source project. And then recently, with the expanding of our business models, also some new initiatives, we decided to introduce Spark into our big data platform. Can you hear me better? Okay. I've been trying to cover logic. I've been trying to divide the slide into three sections. First section more logical is about why Yahoo even bother about Spark. And the second I will talk about how we bring the Spark and Hadoop together at Yahoo. Right? And finally we may talk about some technical details if you guys still interested in this topic. So let's start with the business motivations why we were interested in Spark. So as many of you know, Yahoo in some way, we were started with our homepage, and our homepage was the crown jewel of the company, and we have a talent team of editors select all those articles for our users. Then in 2012, we decided to take a data-driven approach. So logically, what we are doing is the user to cleansing all those data we have to identify the top articles in the Yahoo have been have been lost. And then for all those, so logically you can listed 100 also articles. For those 100 articles, we decided to then apply machine learning to come up with the mathematical models. So when you visit our homepage, at that point, we basically apply your interest against that mathematical models to identify the top 5 articles for you. And then we put those top 5 articles into the module the module we call the today module. Okay, so that was what we did. With that effort, what we saw was, as you kind of mentioned over there, the critical slope of our today module increased 300%. So that was like, big surprise for us, or big data, that's a huge difference for our business, right? So with that, so we say, why don't we do it even better, right? So what we decided to do in 2013, one of our initiatives was around the personalization. So what we wanted to do is bring personalization, in 2012 we did the today module, right? 2013 we're going to expand across. So with our new leadership, we decided to start from our biggest properties as our homepage. So if you visit our homepage, most of the pieces of the components in the homepage is personalized. So, starting with the homepage, the today module on the top. Then below that, there's this thing called we call streaming modules. So they have the endless streaming of the articles and ads, specially selected for you. And then also many other stuff. Right? So if you look for the article here, in the streaming module here, then you could have a lot of articles for you. And for the one here, as the top, the first one was about some political interest for me. And the second one was about high-tech stuff. So clearly it was selected because of my interest, right? Then personalization simply is not just for the web. And with the Yahoo, we are pushing for the mobile. And the personalization is very important for our mobile launch. So recently we launched our Yahoo native app for the mobile things. But with this screenshot here, you see our iPhone app. Right? So the article over there, again, you can see, it's quite, specifically kind of the sense, it's not like they, for everybody, to enjoy, but it has a lot of features just for me. So that's the home. Then some of you may notice that we relaunched many of our properties as well. For example, this is the screenshot of the Yahoo Finance. Right? And then if you look into the website, again, this is a big module on the top, and the streaming of the articles for finance stuff. And for the mobile side, again, here, all the finance stuff. They are personalized mainly based on the set of the stock codes and individual user is following. So those are a few examples of the personalization. Right? Then the other side, right? Then you think about it. Then other side is our search is another major properties of Yahoo. And then, in the simplest land, what you can do is, just when the user is jumping into the search, you just find all sorts of web page for you. So what we decided to do is, web page is good. But Yahoo has all this vertical stuff, like images, videos, all this other stuff there. So why can't we understand the user's interest based on their search term, then mix those vertical content into the search result page. So what was this thing here was I was a person who was searching for the stuff. So you see that for my website, you see the first module over there was the videos, right? So it found all of the videos about the term I was searching. And then in the middle there's one of the web page. And in the bottom there the images related to that thing. Again, how you think about how you know the question will be how you come up with those. Again, we are doing machine learning. We come up with the mathematical models, and then when the user comes in, we apply the mathematical models against the search term to come up with a score, and then we apply our business rules to decide what's the order to display those things. Again, so this is another example of the data-driven approach to make our, try to improve our business. So now let's step back. Okay. Across all those use cases, logically, here's my conceptual architecture of Yahoo. What do we do? Right? We apply what I call is data science at the scale. So what we are doing here is taking huge amount of data about the users, about the content, processing them. And the way we do it is we apply the machine learning technology on it. And with that from those machine learning, we come up with the models. Then we apply those the new models we have. We continuously update our knowledge about our users, about our product. And that's what you get from our homepage, that's what you get from our search. So how to make this to happen? So there's the man sitting behind his work. The man we call data scientist. So I think for us, it's really important to have such a data scientist do a very product work, right? So what kind of model do you come up? How quickly do you come up? All those things. They are determined in some way has a huge influence to how much what kind of user experience our user going to have, how much money Yahoo may be making, right? So a group of us, we belong to this thing called the big data platform. So our job, one of our main job is to make sure we come up with solutions to make that data scientists be able to do this. Okay. So now this is looking into this. So what's the challenge about the data scientist role? So I will enumerate a few challenges for this guy. So first thing what I call is a science challenge. So now remember I mentioned the home page, right? So let's look into this streaming module for a few minutes. So there's a few things over here, right? So thinking about the potential pool of the content we have for that module, right? Logically, we could have millions of potential items to pick, right? We have also the genetic news, it could be the socials, messages that people have from Facebook or Twitter, all those things, right? So that's the millions of things. So now, for those millions of those things, how you want to do the mathematical models? In the 2012, what we did was, for the today module, what we did was, because for the today module, we have 100 or so articles. For those 100 or so articles, each of them, we just create one mathematical model. Now you have millions of articles. Are you going to create millions of models? We decided no, that's not the good skill. So what we wanted to do, we have one single models for all the millions of articles. So that's so that's our desire here, right? Then when you look into all those articles, then you think about how you come up with models. Right? So there are some of the things that we wanted to base on, when we define those models, it's based on the features. In Yahoo, when we design our model here, if you look in your spare time, look into our homepage. When you select those articles, it actually explains to you why we select that one for you. So for this one, I select the open. For the second article I mentioned earlier on, in our homepage, it mentions we select this article because you are interested in the information about IT, about the technology, about Microsoft, about other people. Think about it. So there's those things are logically for every Wikipedia entities, we treat as a potential attribute. So there's a lot of features one need to have, right? So maybe this is more complicated to think about this personality. It's about it's an object, it's object function. So very simple one you're going to think about. Let's make sure the article is relevant to users' interest. So the relevance is one of the important things for it. But that's not all. Then the second, another one could be, flashness, popular. How popular is the article? How flashy is the article? You made something is interesting, but it's not very popular enough. The user may not care. Right? Then the other side, you could find all those things. You want to have a diversity of the articles in your page. Right? So your object function could be quite complicated. Now that's why we could not just apply some machine learning algorithm on the shelf. We need to have scientists do their work. That's why we create a big box, box. So some of our scientists, with their background of their PhD, those things, let's apply logistic regressions to do the classification, right? So we currently actually, if you look at our production, it's mainly the logical regression-based model that we have for this. But on the other hand, some of our other data scientists are looking to the collaborative filtering. Because that problem is logical regression, right? So what's that going to give you is all the articles, you kind of keep reading those, As a user, when you visit outside, you want to expand your knowledge, horizons, If you keep it based on your previous interests, will not be able to discover those articles for you. So as a result, so if you think about collaborative filtering, it's based on, people with similar your interest, what kind of other articles are they reading, Then you can imagine, you can expand those things, how about the targeted articles? So again, imagine, that's why I call it a science challenge, There's the business model, say, your data set is kind of complicated, and your object function is complicated, and then you do not know what is the ideal algorithm at all. So now, talk about something simple, right? What I the second one, what I call it the speed and it's the speed challenge. So part of the thing is, if you think about it, people have many online properties have been doing the machine learning for their things. For them, they have Netflix, they have Amazon, they're doing machine learning. Here, for the machine learning in Yahoo, we face some additional challenge. Partially it's because it's a freshness. So the article, so here's some information I'm sharing with you about the form of today model. So each curve over there was represented the click-through rate for an article, during the total rate is about 2 days amount of data. You see how the click-through, rate for an article change over time. But some of them kind of, was very popular at the beginning, afterwards just disappeared, right? Nobody cares about it. So in order to catch those kind of things, so clearly you need to be able to come up with a model very fast. So more specifically at Yahoo, we are aimed to come up with machine learning models every hour, if not faster. Okay? Then the third challenge I want to call is the scale. So partially there's the two sides of the scale. So one is the amount of data we have, right? As many of you know, Yahoo has been, we built Hadoop because of, we have a huge amount of data, right? So I think have 100 petabytes of data Yahoo we have at hand. So from our data scientist point of view, they needed to using all those data to come out with a model, right? Because without a model, you just couldn't do your PhD at the university. So they needed to use those data, huge amount of data, to build their models and to looking for obvious angles. And one way you could do it because data is so huge. Then the question is how you access it, right? You could not afford to make a copy of those data to something, especially the data is keeping changing. Then the second is from our data scientist point of view, Hadoop guys, you have 35,000 machines sitting there, let me use them, I mean, that's why many of them joined Yahoo because of that. It's a playground for them with all those machines there. Right? That's why they love them. So what we want here is that, so at the end of the day, we want to have a solution to address all those challenges along the size, along the speed, along the scale. So here's what we come up. So our answer is bring Hadoop and Spark together in a single distributed cluster. So what we are saying here is that Hadoop continues going to be our core technology for our, batch processing. On the other hand, going forward, Spark will be a preferred solution for iterative processing, especially the thing like machine learning as I enumerated through all those use cases. And also the MapReduce job and the Spark job going to be run on a single cluster. We're going to leverage the technology. Yahoo has heavily contributed to this thing called the Hadoop Yam. That is the new resource manager under the hood of the Hadoop 2.0. And also the Hadoop job, Spark job, will have access to the same set of data all those data sitting on or HDFS, all those data sitting on HBase will be available for both sides. So no more data movement, no more complaints about the access latency, everything. Okay? So what we are, so by bringing them together, we hope we found a decent solutions for the challenge along the size, along the speed, along the scale. I think in the next few minutes I will try to give you a few examples on those. So end of the day, we believe the Spark bring a, Spark API and its library for machine learning will increase the productivity of our data scientists. And for the speed, because the underlying architecture design and the heavy leverage of memory of the Spark things going to dramatic, hopefully it will reduce enough of the latency. I will give you some indications of that. And then scale, as I mentioned earlier on, because all of them are going to build on top of the single cluster, single resource managers, the scale problem will be solved for all scientists. From our data scientist point of view, all the data are available for them anytime. So let me give you some indications about what kind of benefits Yahoo is gaining from this new architecture. So let me start with a very simple, right? This is the story I'm going to give you is Yahoo Taiwan e-commerce site. So as many of you do not need to read the Chinese, but the end of the day here is, imagine, just like our many e-commerce site, right? When you are purchasing some, item, they tend to try to recommend a similar thing or related item for you. So for this shopping site, for Yahoo shopping site, we have those. Logically, when you are viewing something, we say, here the other three people are viewing, here's the article, stuff other people are buying, kind of stuff, right? So, one of our data scientists tried to do, okay, I heard about the Spark, I heard of the dish, let me give it a try. He was able to come up with a simple machine learning algorithm in Spark. 30 lines of code. With that 30 lines of code, using a small number of machines that he had at hand, he was able to build the model in 40 minutes. Until then, he had been heavily, using our Hadoop stuff. Quite amazing. And the power here, as I will explain later for the Spark, partially because, Spark enable you, leverage your memory, be able to describe your program like an arbitrary tag. You do not need to do unnecessary I/O operations. So here's another story I'm going to give you. So as I mentioned earlier on, our streaming module kind of is a very important investment we have in 2013, right? Among them, we give you all the articles. In addition to the article, we decided, we may want to see some ad. So we insert those ads over there. So then we give you different color so that make sure you understand so that ad. But so that ad try to be close to your. So the initial version of our machine learning algorithm was written based on a library called BW library, and it's very popular for the machine learning industry, community. It was originally developed by Yahoo research scientists, and currently it has a quite popular. Then one day, another data scientist in our lab said, I tried to do something on top of VW, but I do not really know how to explain this because it's very complicated. It's a C++ code. You know, the guy just do not get his hand on. He said, you know, let me do Spark. Again, he wrote a few additional number of lines of code. 120 lines of code for his new algorithm in Spark. And then instead of take off, you know, then again his algorithm was be able to produce models in certain ways. Very effective. And to me, those are the good things that is from business. As a technology provider for him, I'm more interested in the second bullet. The thing I was more impressed by how quickly he was able to deliver his first version of his algorithm. So then I remember that was a Friday. Like in the afternoon, and a small team of us, we say, okay, so we think at this point Spark is good enough for us. We deliver the app package. So at Yahoo, it's many of us, many of our developers depend on this thing in packages. So we made the package available. 2 hours later, we got an email from this guy. He said, you know, Spark folks, I just deployed my first version of my algorithm on the Hadoop cluster. I was really super, you know, really enjoyed that moment because, you know, usually for data science, without that software, data scientists are going to spend all, you know, not hours, days, weeks to set up, you know, to find the machine, to set up the search, and try to get this thing up. Because at the end of this, they're not, you know, they're not a system guy, right? Okay, so those are the, I think, the success story. What we, I think, you know, just 2 of them I want to share with you. And for the folks who are not familiar with Spark, let me give you 2 slides overview about Spark. So the Spark was a technology originally developed by our friend at the Berkeley Amplet. And it was the desire was saying, you know, let's leverage all the memory resource we have in the computers. And we will do the distributed computations and make sure, and we will try to be compatible with the libraries. And you know, leverage all the Hadoop stuff like HDFS. Right? And they have 2 goals in that thing. Their first goal is they want to make sure, you know, it's easy, you know, the execution of this thing need to be faster. So that's why, so the thing is, they do not like this map reduce, dump the disk, map reduce, dump the disk concerns. They want to be able to, like, you know, arbitrarily to model your applications. And you want to be able to leverage the memory more efficiently. So they come up with this thing called RDD, I will explain in next slide. And the second thing they focus on was to provide a high-level APIs in a language of, you know, of logic of the community choice. So they start with the Scala, add the Java, Python, you know, all those things. And then, so that's the baseline of the Spark. Then on top of the Spark, they started adding the additional interesting stuff. So one thing called Shark. Shark is a SQL layer on top of the Spark. That is aimed to reduce the latencies one may have faced in the thing like Hadoop. Right? Then on top of that things, they even did this thing called BlinkDB. BlinkDB was saying, you know, many times you just try to find an answer not needs to be very precise, but the other will be fast. Then the other side, with all those PhD students over there, they started building additional stuff. like machine learning stuff. That's the graph processes. So for example, here's